Building new projects most of the time requires working with new components and ICs, but understanding functionality of every new IC becomes complicated without a proper idea. And that's where datasheets help us out. But the real struggle begins when we see these documents, as they come with these many pages for smaller ICs or sometimes with these many pages for larger ICs like microcontrollers. So, in this video, let's talk about how to use these complicated looking sheets to understand the IC and get started with building a project. Let's first consider the simplest IC, that is the grandfather of all ICs, NE555, and grab a datasheet for it. These documents can easily be found by a simple Google search or definitely on an electronics component vendor like DigiKey. Now the first thing we notice by looking at the first page of the datasheet is that the heading says Precision Timers. This obviously states that this IC can be used to build timing circuits, which is also confirmed by the features listed on the same page. This page also consists of an example application for the IC, descriptions on the basic working of the IC, and for mechanical details, the package information, which in our case, as we need breadboard compatibility, is PDIP, that stands for Plastic Dual Inline Package. Moving on, then we have pin configurations that maps the functionality of each pin and also description of each of these functions. Then we have a very important topic of specifications, which provides us with the operating voltage range, which here is 4.5 volts to 16 volts, which means we can power it easily with a 5 volt of our Arduino as we lack a professional power supply. We can also find the information for the output current, which here is 200 milliamps, which means if we intend to glow a LED at the output, we need to be sure of using a proper current limiting resistor. After this comes a very descriptive functional block diagram which describes working of the entire IC. So let's look at it more closely. Firstly, we have three 5 kilo ohm resistors between VCC and ground, which form a beautiful voltage divider with voltages of 2/3 VCC and 1/3 VCC at these points. The circuit further has two comparators, in which the first one has its inverting end connected to 2/3 VCC and the other end to the threshold pin of IC, which means when threshold is greater than 2/3 VCC, it outputs high and vice versa. However, the second comparator has its non-inverting end connected to 1/3 VCC and inverting end to the trigger pin of the IC, and thus when the trigger pin has voltages greater than 1/3 VCC, the comparator outputs low, and vice versa. The outputs of these comparators are further connected to a SR latch, with reset input connected to comparator 1 and the set input connected to comparator 2. Then the inverting output of the latch is connected to the base of a NPN transistor, whose emitter connects to the ground pin and collector to the discharge pin of the IC. Thus, when base is high, the charge at pin 7 is discharged to ground via the transistor. Also, the latch output is also connected to the out pin of the IC via an inverter. Finally, the const pin, which can be used to alter the voltages at the divider points, but is usually connected to a 10 nanofarad capacitor for stabilization, and the reset pin, which is connected to system reset of SR latch, immediately resets the output of the NE555. With all this descriptive knowledge, let's move on to experimenting with typical application circuit of the astable multivibrator, which is just a fancy way of saying square wave generator. Here, let's just try to replicate this circuit to get the output. We just need to connect the charge and discharge circuit at pin 7, 6 and 2 a decoupling capacitor at pin 5 with also ground connected to pin 1, power from the Arduino since we are using that to power our circuits at pin 8 and 4, and finally an output indication LED at pin 3. And that's it. After the power up, we have a circuit working. But wait a minute. What about the values for these resistors and capacitors? We can find information for them in the formulas here. We can see that they are used to set the timings for the output waveform. RA, RB and C for setting the pulse high time and just RB and C to set the pulse low time. Let's try to modify these formulas and get the high time to nearly 1 second. By simple substitution, we have the values of 15 kilo ohms for the resistors and 47 microfarad for the capacitor. And with adding these new values, it looks like it's working, but without a proper oscilloscope, it's hard to know if the timing is perfect. So let's try to use an Arduino to measure the timings for us, as however, we are using one to power the IC here. I have written a simple program using the pulse in function that measures the width of the pulse that is supplied to pin 7 of the Arduino and prints it out on a serial monitor screen in seconds. Now, if we upload the program and connect digital pin 7 of our Arduino to the output pin 3 of our NE555, we can see width of the pulse on our monitor. Pretty cool, I guess. Although this is not a perfect measurement, I think it does the job for this experiment. As we can see, the output is fairly close to 1 second because that's what we said, right? With all this experimentation, there is much more the IC can do that the datasheet teaches us. With characteristics graphs, design procedures, package details, and even with applications like pulse miss detector, there are a lot of cool things that the datasheet tells us about. And for microcontroller ICs, there is even more, like pin multiplexing, register addressing, interrupt handling, power management, memory management, and much more, which is definitely a topic for a future video. And if you'd like to try out any of the circuits shown in this video, you can find all the schematics and code on my GitHub page linked in the description below. Anyways, that's it for now. Hope you liked this video and also learned something along the way. And if you did, please like, share and subscribe and let me know if you have any suggestions in the comments below. See you in the next one. Until then, keep learning and keep growing. Peace out.